Easy, easy. This test is done for College Board. Better watch out. I'm getting an 800. 3 more questions to go. Let's go to the next one. In the figure shown, point A, B, C. Oh, a circle question. Not my best topic, but okay. Let's just give it a try.
A few moments later.
You know what? I'll just skip this one. One question won't kill me, right? I will get a 780. We're good. We're good. Let's go to the next one. The circle shown. Another one? Okay. Okay. 2 wrong question, right? Still a 740. Still Ivy League material, right? Let's go to the last one. What's up, these attackers? Today we're going to go over two types of circle questions that show up on the SAT. And if you're taking the SAT, then I personally guarantee you that you're going to see these questions on your test. They are very common circle questions, and if you don't know how to solve them, then you're going to miss them, just like how the other guy did. Now on SAT, we have 2 types of circle questions. 1, properties of circle, and 2, equations of circle. And we can have too many different versions of questions under each type, but we're going to solve 4 questions from each type in this video, and I'm going to show you how to recognize them and solve them quickly using Desmos. So don't let your zoomer brain to click off this video. Sit back, relax, and watch till the end, because I promise it's going to worth your time. Now, a pro tip here: if you want to increase your SAT score, not just the math, maybe you want to increase your English score, then check the free one-on-one tutoring that we provide for a limited number of students. Link in the description. All right, now the first type of question we will go is properties of circles. So here is the first question that we have. The question says the point P is the center of the circle in the figure shown. What is the value of x? So we're looking for the value of x, and P is the center of the circle. These angles are 25. So what we can do here, this is 25. Let's make it here, and here is 25. What we can do, we can divide this way. So we know that this side is radius. This side is also radius. So this is an isosceles triangle right here. This angle and this angle are the same. So here should be also 25, right? Here's 25. So the same is going to happen for this triangle here. This is also isosceles because here is radius, here is a radius. So this and this also are going to be 25, right? This is also 25 degrees. Now what we can do, okay, we got it. So here's 25, here is 25. I'll just write 25 here. So what is this angle then? So in this triangle, here's 25, 25. What is this angle? Here's going to be 180 minus 50, right? Sum of these is 50. So here's going to be 180 minus 50 is going to give us 130. So then this angle is 130. This angle is also 130. So the whole total is 360, right? So we're going to have 130 plus 130 plus x should be 360. That means x is going to be equal to 360 minus the sum of 230 is going to be 260. So that is going to be 100 degrees. So x is 100 degrees as the answer. So these are properties of circle questions. You just have to know properties of circle, that the inner angle is 360, or that the tangent line to the circle, the radius is going to be perpendicular, which we're going to discuss in the next questions. Here is a similar question to this one that I want you to solve. It's just the same one, but the opposite way. So you have to work the opposite way to solve this question. I'm not going to solve this one. So pause the video, you solve this question, and comment your answer in the comments. And I'm going to like your comment if it's a correct answer. Now, here's the next question. In the figure shown, point B and the center of each circle lies on AC. The ratio of AB to BC is 4:1. If the area of a small circle is 72, what is the area of the shaded region? So we're going to find the area of the shaded region. The ratio, it says the point B and center of circle are on AC. Okay, so AC is the diameter of the large circle, and the centers are on this line. So the center of the larger circle and the center of the smaller circle are on this line. Awesome. The ratio of AB to BC is 4:1. AB to BC. So that means here to here is 4 to 1. So that means if BC is x, then AB is 4x, right? So this to this is 4 to 1. If this is x, this is 4 times that. That's what it means here, ratio. If the area of the small circle, this one, is 72, how do we find the area of the circle? We do pi r square, right? So let's write pi r square equals 72 for the small triangle. Now, what is the radius of the small triangle? I mean, a small circle. Here is going to be the radius of the circle, which is going to be 2x, right? 2x here, and then 2x here, half of the 4x. So you get 2x as the radius of the circle. So that means I can plug that 2x into radius. So I can say pi, rather than r square, I will say 2x squared equals 72. So that is going to give us 4x squared pi is equal to 72. So what we can do now is x, divide both sides by 4, x squared pi is equal to 72 divided by 4. Of course, I will use decimals here. 72 divided by 4 gives us 18. So I'm just going to write 18 here. Okay, so let's just keep it that way. X squared pi is 18. Now, to find the area of the shaded region, we need to find the area of the larger circle, then minus the area of the smaller circle, right? So the area of the larger circle, this one, minus the area of this one is going to be this shaded region. So how can I find the area of the larger circle? So we're going to still do pi r squared, but this time the radius of this circle, the diameter is 5x, 4x plus x is going to be 5x. So the radius is 2.5x, right? Because here total is 5x. So the radius of this one is going to be 2.5x as the radius. So I can put that there. So it's going to be pi times 2.5 x squared is our circle's area. Now we can do, what is 2.5 squared? Let's see that. 2.5 square is 6.25. So we can write this 6.25 pi x squared. What was pi x squared we just found here? Pi x squared is 18, right? So I can put 18 here. So this is going to be 6.25 times 18. Let's just do it here. This thing times 18 is 112.5. Now, the rest is 112.5 is the area of the larger circle minus 112.5 minus the area of the smaller circle, which is 72. So 40.5 is our answer for this question. 40.5 is the answer for this one. That is it. The next question, let's move on to the next one. So this one, we have to, so the property that we're going to use here, this question says the circle shown has center C and diameter AB is the diameter if we have the sine of PAB, this angle, PAB. So this angle, the sine of this is 39 over 89. What is the value of cosine of PBA? PBA is going to be this angle. What is the cosine of this one? So the property that we need to know here is that if a triangle is inscribed in the circle and the one side of the triangle is the diameter of the circle, then this triangle should be a right triangle. So that means here the question said that AB is diameter and AB is one of the sides of the triangle. So that means this triangle is a right triangle. So here is 90 degrees, always. Okay, this angle is the 90 degrees angle. Now the rest is easy. I know that sine of PAB is 39 over 89 and sine is opposite over hypotenuse. So the opposite of this angle is 39 over 89 to the hypotenuse, right? Opposite over hypotenuse, which is the in front of the right angle. So I have 39 over 89. I just wrote those sides. By the way, this doesn't mean that the sides are, the length of the side is 39 and the length of the side AB is 89. This this just means that they have this proportion. Okay, we just write this proportion. And now we're looking for the cosine of this one, right? And the cosine is adjacent over hypotenuse. So what is the adjacent of this angle? It's this one. Hypotenuse is this. So the cosine of this is going to be 39 over 89 is the same as this one. You could also use the complementary rule that says in the right triangle, like we can have use the complementary rule that says the sine of alpha is equal to cosine of 90 minus alpha. Here, why do we have 90 minus alpha? Because in right triangle, let's say is 90, here's 30, here's 60, here's 60. Okay, let's say we have this triangle, it's a right triangle. The sine of this is equal to cosine of this, and we say sine of alpha, so sine alpha is 30 degrees here, is equal to cosine of 90 minus alpha. 90 minus 30 is 60. In the right triangles, always this angle, whatever this angle is, this one is going to be 90 minus that, because the sum of these should be 90. Here is 90, so the sum of these should be 90. So whatever here is going to be 90 minus the alpha, right? That's why we have this. We can also write this the opposite way. We can say cosine of alpha is equal to sine of 90 minus alpha. So this is complementary rule. You can also use that here. So that means whatever the sine of this is equal to cosine of this, or whatever the sine of this one is equal to cosine of this, vice versa. You got the idea. All right, this is a really good question. It has been repeated on SAT a few times, and it is a hard one. So try to do this on yourself, and let me see if you could do it. And I will be doing, like, we're going to do it now together. So it says in the figure shown, point A, B, C, and E lie on the circle, and AB is less than BC. AB is less than BC. That means this side is smaller than this side. Okay. Segment AC is perpendicular to segment BE. AC and B are perpendicular. Here's 90 degrees. And BD is root 226. BD is right here. So here's root 226. I'm going to just write that here. And the diameter of the circle is 115. So here is 115. If we have this, what is the value of R? So we want to find CD over AD. CD over AD. This is what we want to find. Okay. So what we can do here. So again, we're going to use that property that we discussed in the previous question. Here, the question says, we don't know if this is diameter of the circle, but if you look at this triangle, it is a 90 degrees triangle, a right triangle. So that means this should be the diameter of the circle. So we can also work opposites. If it could say here is the diameter of the triangle, of the circle, then we would know that this is a 90 degree angle. Okay. Now we know that this is the diameter here, and this is 115 as the question said. So I'll also write that here. 115. Okay. Now guys, we have similar triangles. We have this triangle, and this large triangle. So all these three triangles are similar triangles. We have to use the proportions very well, that we can take out this side and this side. Okay, we want to make equations using this side and this side. So what we can do here is I'm going to use this triangle, the small triangle, and I'm going to use the larger triangle because I know this side. So this side of the larger triangle, and I'm going to use this triangle because I can find this x and I know this side of the triangle. Okay, so we're going to use those. I'm going to just mark them up for you, this one and the large one. Okay, so let's go on. Now in the small triangle, here is the hypotenuse. This is, so I have to use these two sides rather than hypotenuse. I'm going to use these two sides to make our proportion in similar triangles, because I know this one and I'm looking for this one. So this side is the larger side. So I will mark them up. See, we have hypotenuse, we have long side, we have short side. And now look at the larger triangle. I have hypotenuse, the larger side, and the short side. So these are proportional with those in this small triangle. Okay, so now I have the larger side here, the longer side. What is the longer side in the large triangle? It's right here, right? So that is proportional with this. So root, I will write root 226 over the BC. Okay, so the longer side in small triangle over the longer side in large triangle is equal to another proportion here. This side AD small, so I will call it X. Here is X. X over the small side in this large triangle, which is this one actually. Let's not do it that way. Or actually we can do it that way. Yeah, then we can, okay, it's gonna work. So in this triangle, the small side is here. So here is the small side for the large triangle. So these are proportional, right? So the X over AB. Hope it makes sense, guys. Okay, now what we have is a proportion, but we have three variables, this, and this. What we can do, we have to write another equation, okay? So we have to write other equations to make up to this. So we know that AB here and BC here. So I know AB square plus BC square is equal to 115 square using the Pythagorean theorem. So we can also write that. So let's do a cross multiplication in this. Write it as an equation. So we will have AB root 226 equals BC times X. And we can have AB square plus BC square equals 115 square, right? And I need to make up another equation maybe. Because we have three variables, see, A, B, B, C, and X, we need three equations. So the number of equations in the system of equations should be the same as the number of the variables. So I need another equation here. So I have first one, second one. Let's write the third one as this one. Using this triangle, we can say x squared plus this square is equal to ab squared. Again, Pythagorean theorem, right? So I'm going to write x squared plus 226 is equal to ab squared. Now, I have ab squared here. So put that expression into this, substitute that there. Okay, so we're going to have x squared plus 226 plus bc squared equals 115 square, and we have this one, AB times root 226 equals BCX. So I want to make like two variables here, not three. So I will substitute it again, this one into AB, but I will put root here because this is AB squared. So I'm going to say the root of x squared plus 226 times the root of 226 equals BCX. Now we have two equations, this and this. Both of them are in terms of BC and X. BC and X. Okay. Now we can put this into Desmos and just Desmos is going to solve it for us. Rather than BC and X, I'm going to put Y and X. Then it's going to work on Desmos because Desmos doesn't know what is BC. So we have to put in terms of X and Y. So I'm going to put the first equation, x squared plus 226 plus y squared because of BC squared equals 115 square, right? And the second one, we're going to put we have to put root of x squared plus 226 times root 226 equals y times x. So let's zoom out and see what we have here. What are the solutions? The x-intercepts are going to be the solutions, right? So I have this one, this one, this one. We have four solutions. So which one should we go? Right here. So the x-coordinate is what we're looking for, right? This is the x is what we're looking for, not the BC. BC is here. That's not what we're looking for because we want to find CD over AD, right? And if I find AD, I can easily find CD as well because it's 115 minus AD. So we're gonna do, we're looking for x, so the x coordinates are the answers here. It's 213, negative, and 0. Of course, x can't be 0 or negative, so these are already eliminated. So we have 2 or 113. Now, if x is 2, if this one is 2, then this side is going to be 113, right? Because here's 115, so 2 minus 150 minus 2, you get 113. If the answer is 113, if here's 113, then here's going to be 2, which doesn't make sense because this side is the longer side, right? So here's 2, here's 113, and the answer is CD over AD. 113 over 2. 113 over 2 as the answer. You can plug it exactly like this. It's 5 characters, or you can make it, plug it as decimal number. So 113 over 2 is the answer for this question. Now let's see another way that we can, a quicker way. Well, you can, so I want you to, as a practice, because this is a hard question and important one that can show up in the second module. I've seen this shown up, so I mean it, it can show up. So try to solve this question again, but this time, rather than taking this triangle and the larger triangle to make proportions, take the small triangle and this triangle to make proportions. This is going to make much more sense. You're going to have only two, this is going to be even easier. You're going to have two equations if you do it this way. Two equations. One is going to be from the proportion that you will have two variables, okay? And the other one, so here, put here y, okay? Put here y, so you make x and y. So in your proportion, have x and y, and you're going to have only two equations, one from the proportion and one from, you need to make a second equation using x and y. And you can do that as saying x plus y is equal to 115. Boom. So make sure you do that, and I'll write the proportion right now. So make sure you do this before I see it. So if you've done it, you're gonna have the proportion like this. You will have this triangle and this triangle. So the short side over short side is going to be x over root 226 equals the long side. So the long side in the, I will write it, x equals root 226. This is the second way, equals the longer side in the small triangle over, so the root 226, over the longer side in the larger triangle, this one. Longer side here is y. So root 226 over y. Now if we do cross product, we're gonna have xy equals 226, our first equation, and second one is x plus y equals 115. This is the second equation. Put them into decimals, you're gonna see the answers. This is way much faster and easier if you take these two triangles as the triangles to make the proportions. You can take any other different triangles again. You're gonna anyway find the answer for this question, but it will just take more time to do it. You will have to make more equations to be able to find. So you want to take the best triangles that can give you the least number of variables in your equations. So this, if you take these two triangles, you're gonna have the least number of the variables in your equations basically. And if you, by the way guys, if you need help with your SAT, not just the math but increasing your total SAT score, then definitely check out the one-on-one free tutoring that we provide. It's completely free, and it's a one-on-one service, not a group call, and it's a free service. So we have limited, that's why we can take only a limited number of the students. And if you're serious on increasing your SAT, you can just check it ASAP before the spots are out, and I'll see you there. Now let's go on to the second type of the questions, which is equation of the circles, right? So you have to memorize the equation of the circle that is in this form. This is the standard form of the equation of the circle, and these are the centers of the circle. This is the radius square. So I will write the form of the equation circle here so you can get an understanding better here. So it's going to be, it is x minus h square plus x minus k square equals r square. So the hk is the center of the circle, and this is the radius. Okay, I have a very bad handwriting, I know that. So notice that here the signs of HK change for the center. So for example, in this equation, 6 and 3, so we have them here. So the center of the circle is -6 and -3. Okay, and the radius is square root of 170 because this is radius square. Okay, so this is what you have to know about the equation of the circles. Now let's go to the question. It says the equation above gives a circle in xy plane. Line P is tangent to the circle at the point this. What is the slope of the line P? The function f of x gives the graph of line P. Write an equation for f of x. So we have like two questions in one question here. Okay, we have line P that is tangent to the circle at this point. So we have the circle, and the line P is tangent to the circle at this point. So this point is both on the line P and on the circle. Okay, so if I have the circle this way, and here's the center of the circle, which is -6, -3 for this circle, and let's say here is the tangent line. Okay, this point is -15, 3, which is both on the line and on the circle. And we know that this line, the radius, is always perpendicular to the tangent line. So that is a 90-degree angle over there. And we're looking for the slope of the line P. This is the line P, okay? So how can we find that? If we can find the slope of this line, we can do negative reciprocal of that, and it's going to give us the slope of this, right? Because the two lines are perpendicular. So how can I find the slope of this line? Using these 2 points. Let's go. So the slope of the line is the y, so 3, the y2 minus y1, let's just write that, y2 minus y1 over x2 minus x1, that is going to be 3 minus -3 over -15 minus -6. Okay, so that is going to give us, let's write it here, 3 plus 3 is 6 over -15 plus 6 is going to give us -9. And that is negative, simplify them, 2 over 3, right? So here is -2 over 3. So what is the slope of this one? Negative of reciprocal of this. So 3 over 2. That's it. So we got the slope of the line P. Now we have to write the equation of this line. To write the equation of the line, we need one point and a slope of the line. So if we have the point and we have the slope, so we can write the equation easily. So let's go ahead. This is a line. So the equation is y equals mx plus b. So m is 3 over 2. So we can write y equals 3 over 2 x plus b. And we can plug this point that is on the line to the equation and find the value of b. So let's plug that. 3 equals, so 3 goes into y and -15 is going to go into x. 3 equals 3 over 2 times -15 plus b. Here, this is going to give us -45 over 2. So b is going to be 3 plus 45 over 2. That is, let's just write it on Desmos. It's better to always do it here. Avoid mental math. 3 plus 45 over 2 is 25.5. So b is 25.5. So the final equation of the line would be y equals 3 over 2x plus 25.5 as the answer. All right, we got the next question. In the xy plane, the graph of the equation above is a circle. Point P is on the circle and has coordinates of this. If PQ is the diameter of the circle, what are the coordinates of point Q? So this equation gives us a circle. The center of the circle is, by just looking at the equation, we can say that the center is 6, -5, and the radius is 4. So this point P is on the circle, and PQ is the diameter. So we want to find the other end of the diameter. which is point Q. So we can do this actually on Desmos, right? So let's just put this into the equation, into the Desmos, and just see the circle. So I'm gonna put that here. We have y plus 5 square equals 16. And there we go. Zoom in. This is the circle, right? And let's put the point that is on the circle, which is 10, negative 5. And as you see, the point is right here. So the opposite side of this, which is the diameter, is going to be this point, right? Which is 2, negative 5. So the other way that you can do this is, here is 10, negative 5. The other side, the diameter, if the Q is on the diameter, here is the Q, it's going to have the same y coordinate, the same y value, because the y is not changing, just the x, it's just moving on the x-axis, right? So the y is going to have to be the same, negative 5, right? And as you see here, we have A and C both negative 5s, okay? And the radius is 4. So when we move 4 units this side, 8 units because of the diameter, then we're going to have 2 here. So we will have 2, negative 5 as choice A for this question. Very easy with Desmos. You just plug it there and see the point and see the opposite side that can be the diameter. A circle in the xy plane has its center at this, and the point this lies on the circle. So we have the center of the circle and we have a point that is on the circle. Which of these equations can be represent the circle? Okay, which of these can be the center? So first of all, let's look at the center part of the equations. We know that these points show the center, right? So if this is the center, make sure you pay attention to the signs. The signs will change, okay? So the center of the circle in the equation should be like this, should be 3 and negative 4. 3 and negative 4 right here, 3 and negative 4 right here. So we are between B and D, all right? So these are out. B and D, the difference between them is this radius. So let's find the radius. The radius is going to be the distance between the center and the one point on the line, right? So we can find the distance between these points using the distance formula. The distance formula is x2 minus x1 square plus y2 minus y1 square to finding the distance between 2 points. So using that, we're going to have, let's do the x2 minus x1. So negative 3 minus negative 2 is going to be negative 3 plus 2, which is negative 1. Then square that is going to be 1. Plus 4 minus 1 is going to be 3. Square that, 9. So we have 9. So it's going to be root 10 for the radius, the distance between those two points. So it's going to be this choice B is going to be the answer for this question. All right, we got the last question from the equation of the circles. The equation above gives a circle in the xy plane. What are the coordinates of the center of the circle? Okay, so this time we see a different type of the equation. This is not the type. This is not this type of equation that we see here. We don't know what is the center or what is the radius by just looking at the equation, right? So what can we do here to find the center of the circle? So one way that you can do is manually converting this equation into the standard form of the equation, circles equation. The other way is, of course, plug this into Desmos, see what is the center, what is the circle, and just look at the center of the circle, right? So let's do it that way. 3x squared equals 0. There we go. We have the circle. Let's check the center. Where is the center? So I'm going to click on the circle, and we see two things here. One, we see the y-intercepts here, and the second, the Desmos automatically gives us the 2 points, that the middle point of these 2 points is the center of the circle. Okay, so here, somewhere here is the center of the circle. So what we can do, here is we want to find the middle point of these 2 circles. Of course, the y coordinate, so you see the x coordinate is negative 2 and negative 2 here. So the x coordinate of the center is also going to be negative 2. So that's that. But we just want to find the y coordinate of between these 2 points, right? So what we can do is we can add this and this, divide by 2 is going to give us the middle point of these 2 points. So I'm just going to add this point plus this point The Desmos is rounding these, by the way, so we're not gonna get the exact number, but we're gonna get very close. Oh, we actually got the exact number. So divide by the 2 is 13. Now we could get, because the Desmos is sometimes rounding these up, we could get something like 12.9999, for example, that. So if you get something like that, then you know it's 13. Okay, so if you get, or 13.111000111, something like that, then you know it's 13, because Desmos sometimes round these up and doesn't actually write the number, but here just wrote the number, so we got 13. So the center of the y coordinate of the center, you're going to write it here, is 13, and the x coordinate is -2, as you see here. So the center of the circle is -13. Now you could do the opposite way. You could convert this into the standard form. That would take even longer, but yeah, this is the best way that we can do this question, and how you can recognize. Sometimes you can solve circle questions on Desmos, and sometimes you can't. Not all the questions, circle questions or geometry questions, are solvable on Desmos. All right, that's 2 types of circle questions that we've covered in this video. If I want to go over all different versions of the circle questions, then this video might be 4 hours or something, but don't worry, you can get a full PDF of all circle versions in your free one-on-one tutoring, and if you're interested in that, you can book it via the link below. And good luck on your SATs, and let's get a target score.